be shaped by two words: actions and reactions. The first places us at the table, the second risks us going astray. Actions and reactions. We must choose how we want to define ourselves. Actions or reactions is not the question, but the outcome. Are we going to end up as we react or shaped by what we do? Choose actions based on conscious choices and brave solutions, choices that will define how the Arctic will be after our watch. We know it's difficult. We know it's complicated. We know it can be solved. Making choices and standing by them requires leadership. It calls for more than thinking it, wanting it, wishing it. It requires action. We are here to equip ourselves for the choices we know we must make for a sustainable, viable Arctic for the coming generations. An Arctic future shaped by our actions. Welcome to Arctic Frontiers 2024.
Kjære deltakere, kjære gjester, velkommen til Tromsø, hjertet av Arktis. Vi i Troms fylkeskommune er stolt av å være vertskapsfylke for denne viktige konferansen. Vi skal la oss inspirere, vi skal dele kunnskap, og vi skal prøve å finne bærekraftige løsninger. Verden påvirker oss her i nord. Om det er konflikter, klimakriser, uro eller folkevandringer. Men det er kun sammen vi kan finne felles løsninger. La oss snakke med hverandre, la oss dele med hverandre, og la oss finne felles løsninger. Lykke til med konferanse. Velkommen til Tromsø.
Welcome to the Arctic Frontiers Conference. Since the start in 2007, Arctic Frontiers has brought together key voices of science, policy, business and local Arctic communities, with the aim to transform knowledge into impactful actions that help shape the future of the Arctic region. Today, more than ever, the importance of holistic discussions grounded in credible knowledge cannot be overstated. We are committed to using this platform to contribute to regional development and building competence by sharing knowledge, networks, resources and best practices. We are gathered in Tromsø in the spirit of collaboration, exploration and innovation to make a lasting impact of the sustainable development in the Arctic region. Thank you for joining us in this endeavor.
Velkommen til Tromsø, den arktiske hovedstaden. Her bryr vi oss om de viktigste spørsmålene. Det er klimaendringen, det er geopolitikk og ikke minst det gode liv. Vi har kompetanse og kunnskap til å møte fremtiden, så ønsker jeg dere skal være med på laget og hele uka bruke Tromsø med de mulighetene som finnes her. Ha en fantastisk konferanse.
Welcome to Sápmi. At Arctic Frontiers, we meet to discuss possibilities and challenges of the Arctic, and we do that with a warm heart gazing towards the future.
Good morning, everyone. Welcome to our first session on smart cities. And I think this is a really warm welcome from Tromsø, as you can see outside, unusually warm. And as probably many of you have experienced, this warmth brings not only good, but also bad things. It's very slippery outside. Please be careful. That's a serious threat. Just a few days ago, actually on Saturday, I had local people, telling them about smart cities, and that met extraordinary high interest. There were good discussion, many questions. So I tell you this to emphasize that our work on smart cities is very important, as for science and for public as well. In center of any smart city is their inhabitants, people who live here in smart cities. And for them, we shall work out common, holistic, technological and societal nature-based solutions. That is the goal of our session today. Look from different perspectives on the problems of cities, making cities smart and more friendly, putting people of city in the center of decision making and life. So we start our session. There are several interesting talk today, before coffee break and after coffee break. After coffee break, Alenka, professor from NTNU, will chair the session. But today, before coffee break, we would like to introduce keynote presentation from Johannes Brazowski about Urban Environmental Laboratory, the cutting-edge sensor network for research on livable and healthy cities. Johannes, the stage is yours. 20 minutes, I think.
Here it is. Yes, thanks for the introduction. Good morning, everybody. My name is Johannes Brazowski, and this talk today, as Igor already said, is about the Urban Environment Lab, which is a cutting-edge sensor network for research on healthy and livable cities. I'm pre-warning you right now. This is a presentation which is mostly focused on the Norwegian case, not so much on the international one, but it's very transferable concept. So yeah, it's easy to implement it on a theoretical basis, at least globally. First, shortly about myself. My research domain, or my background, is actually more on the building side, sustainable and energy efficient buildings. But in my PhD, I focused on the urban microclimate and especially large-scale simulations and measurements of the urban microclimate. Now, I'm a research scientist at SINTEF Community in Trondheim, which is about how far? 1,000 kilometers south of here or so, in Norway. But jumping right into the background, we start with noise, which is one of 3 environmental factors that I'm focusing on in this talk today. And same as in most countries around the world, urbanization is moving forward also in Norway. About 83% of people are living in communities in Norway. The numbers are rising constantly, as we can see here on the bottom left. Especially the large municipalities are significantly growing and will grow also in the future. That also has a significant effect on traffic, as we can see on the bottom right. Only the pandemic managed to put a small dent into the curve, but the general tendency, I think, is clear. We will have more traffic also in the future. The result, the consequence of all of this, is that more and more people are exposed to noise. In Norway alone, remember we have a country of 5.5 million people. Over 2 million people live in areas which are exposed to noise over the recommended guidelines. And the numbers are rising significantly. As you can see, in 1999, this was far less. So traffic increases, but also vehicles get heavier and heavier. They get larger. Also, electric vehicles are heavier than combustion engine vehicles. There are about 200,000 Norwegians reported to have sleeping problems, and about 4,000 to 10,000 healthy life years are lost every year Western Europe, the number is at least 1 million healthy life years lost due to noise, which is a huge number that you don't think about every day, I think. Moving on to air pollution. As we can see here, air pollution levels in Norway are generally going down, which is really good. But we also need to point out that we're not measuring everything there is. We're monitoring only a few air pollutants, like those you can see here, but this is by far not everything. So we know, for example, that there are ultrafine particles that are able to cross the barrier from the lungs, from air to the blood, and we don't really have a good idea where they're coming from, how large is this threat to humans. We don't have a monitoring system in place for them, just as an example. So there's an urgent need for research here. So air pollution, we all know that this is a serious problem, and also in Norway, where we in general have very, very clean air, it significantly contributes to the disease burden, and it costs society also huge amounts of money every year to solve problems caused by air pollution. And I think this is really, now you can't see this on the screen, but globally it's estimated that 99% of people breathe toxic air, or air that is above recommended limits. And this is a number that is just mind-blowing in my opinion. A recent study attributes more than 8 million deaths per year to air pollution alone globally. So it's really a silent killer. The third environmental factor is urban climate, and we all know that climate is warming, and in general, globally, it gets warmer and warmer. Also in Norway, 2023 set another gloomy record, and it also started like this in Norway, where we had an unusual early heat wave and unusually early tropical night already in June, even though the second half of the summer was quite wet and cooler than expected. But the problem is real, and heat waves get more and more common in Norway too. So we can see that in the last 30 years, the number of heat wave occurrences has increased significantly compared to the 30 years before. And especially cities are prone to this development because they're warmer than their surrounding by nature, because they're dark and heavy materials that can store the heat much better than vegetation. So especially people that live in cities, and most people live in cities, are affected by this development. But why is this a problem? Well, when we look at what the main principle, the guiding principle in Norway for urban development is, we can see that it's densification and development of junctions. And this is not necessarily a bad thing. It's actually a quite good idea when you look at the reasons. It's on the one hand because compact cities are much more attractive for walking, for taking the bike and taking public transport. Existing infrastructure can be largely used, so you use less materials to build new infrastructure, and you have less impact on untouched nature outside of the cities, which is in generally a very good thing. But all the things that I mentioned just before are also caused by denser cities, by more people living in a small area. And additionally, the main concerns for developers are maximizing area so they can maximize profit. So that often leads to that valuable intra-urban green spaces are lost, which are not only important for recreation, but also for water runoff to avoid urban flooding, and also for climate buffering. So we really need a better knowledge about the actual exposure of people in urban areas to make good decisions. So there's this conflict here, and it's not always easy to resolve this conflict between urban development and noise, urban climate, and air pollution. So we really need to work on our conflict resolution skills in order to avoid making bad decisions. We need informed decisions, to make cities also livable and healthy in the future. But how can we do this? And when I say we, it's not usually the researchers that make those decisions, and we have to keep that in mind. It's usually politicians, it's the urban planning office, it's municipal planning that makes those decisions. So we can only give guidelines, but the goal for everybody must be livable and healthy cities in the future. And this is something that is at least acknowledged by, from the public and politics side in Norway. We can see that in many strategy documents, in many white papers, in many policy documents, that, for example, healthy living conditions and high quality of life in cities is frequently mentioned as a goal. Also, good air quality and less noise pollution. Urban development must be knowledge-based. Health effects and public health risks from climate change and pollution is one of the prioritized knowledge areas by the Ministry of Climate and Environment, and that we have to develop new technology, methods and innovation to make the collection of environmental data more effective and relevant for decisions. So that already underlines the importance, and that what we're actually thinking of and planning to do with this Urban Environment Lab makes a lot of sense, because we're not doing it right now. And it's really important to do that, to have a denser network of sensors, because when we look at least air pollution, what is measured today, we only have very few dedicated stations that measure air pollution. While this is also making sense in a way, because you can draw conclusions from single measurements for a larger city area, it also neglects the fact that air pollution levels might be very different from place to place in the city, and there might be a large local variation as well. Plus, we only measure a fraction of the air pollutants that are actually known to be harmful for people. And when we look at noise and urban climate, we can look a little bit longer for measurement stations, because there is not that much there. Especially regarding noise, there are those noise maps that you can look at, but they're based on the 2016 situation, so also quite outdated when you remember the curves that I showed you in the beginning, that traffic has increased, that people living in cities, the numbers have increased. And it's only based on a sort of a average traffic volume day to calculate an annual exposure. So it's very rough, and it totally neglects the fact that there are also these day-night variations and also spatial variations in a city. Regarding urban climate, well, every larger city has measurement stations according to the WMO, but those are mostly located outside of cities and in a very standardized setting, which also makes sense because we can compare measurements internationally, but they also do not represent necessarily the areas where most of the people live, which is in the city centers and in the really dense places of cities. So for those people, if you really want to know what's the urban climate exposure to these people, the usual measurements that you can find online are not really good, not really suited. And also the World Meteorological Organization points out, or acknowledges this fact by saying that there's a growing need for urban meteorological observations in support of detailed forecasts for citizens, building and urban design, air quality and health. So this is something that we would really like to address, and we think it makes sense now with sensor technology getting more available for everyone, it gets cheaper, to implement a dense sensor network, spread sensors across the city, use the Internet of Things and big data concept to create these huge amounts of data that we also are more and more able to analyze when you think of artificial intelligence, machine learning and so on, to expand and complement existing networks and make these measurements also available to the public for better information. And this, of course, is playing significantly towards the smart city concept. Yeah. But also what we have to keep in mind when doing that is to have good control over the urban setting that we place those sensors in, because every city is very different from another city. One might be inland, another one might be coastal. Some cities are flat, others have a huge topographical profile. Also the density of the locations, building density, vegetation density of the places where those sensors are installed can vary a lot. So we need to have good control over the metadata to make the measurements comparable. So when we look at where this research what research can be facilitated by that, we can see that there we can investigate the spatially resolved and total exposure of people to noise. We can analyze noise sources, frequencies, durations of noise, and there's also positive noise. Bird chirping is much more positive than car noise, for example, even though it might be equally loud, I don't know. We can validate and calibrate our models much better and update those noise maps that I showed you before. We could think about the introduction of a noise label, just like an energy label for buildings. And we could look at seasonal differences of sound patterns. Regarding air pollution, we can do similar things like updating the models and so on, but we can also look at the effect of climate change on air quality, because there are some cross effects with temperature that we might have a closer look on. We can combine outdoor and indoor air quality research, and we should also monitor those areas of a city much better that we know that there are vulnerable population groups living in, for example, around hospitals, kindergartens, schools, and so on. Also, regarding the urban microclimate, we can again improve our calculation models, and we can calibrate and validate those models. We can develop also better models for outdoor thermal comfort, especially, or for example, for cold climate regions and during winter, which is not the research focus globally. We can have better input for building simulation purposes. Yeah. And for all of those environmental factors, we can do before and after comparisons of urban developments and large-scale building projects, and we can also analyze the effect of measures to reduce the exposure. But I think most important of all, working together with the public health authorities, we can look at the health effects of those environmental factors on people and correlate different symptoms to environmental conditions. Just like in this map to the right, you might be familiar with it, where this famous doctor, John Snow, mapped all deaths from a cholera outbreak in London and found out that those were related, in fact, to the water pumps and not the air. So, as a summary, environmental quality is a known problem in cities, also in Norway, where in general we have very little problems compared to other places in the world. But today's practice in urban development is not really in line with a healthy urban environment. The Norwegian government and the authorities have ambitious goals, but we don't have the data yet to support informed decision-making for urban development. Such an urban environment lab, such a sensor network can deliver very, very valuable data for various applications and across several different disciplines, which is really, really important for the future, I think. It works towards the smart city concept. It's of utmost global relevance as well. As I said, it's very scalable, and you can think of a network in every city, every larger city around the world, and you could make comparisons. And the next step is to hopefully get funding to make a feasibility analysis for implementing an urban environment lab in a Norwegian city soon. Thank you so much.
Thank you, Hannes. Very interesting talk. We have time for a few questions.
Thank you, Hannes, for a very good presentation and very holistic overview, of course, and I totally agree that we should go in this direction. One concern which I saw on your slides, but maybe it is not concern, maybe you got only this information, is that you showed us the data from 2019, 2020. So do we have data from today, or we are dealing with past data?
I tried to get the most recent data available, and if it says 19 or 2020, let's say, then this is the most recent data we have. But as everywhere, this is a huge problem, of course, that sometimes we base our decisions on old data, so we really need to make sure that we get as recent data as possible. And I think such an urban environment lab, at least, continuously measuring and updating and not only having these point measurements in a single specific location and at a single specific point in time, this is really what we need to keep track with the developments, also regarding urbanization and different patterns of mobility and so on. Cities change all the time, especially the largest ones. They are redeveloped, industrial areas are changed to residential areas. That completely changes the traffic patterns and so on. So yeah, you mentioned a very important point.
Yeah, so it means that we need better technology and to sensors and connect with better technology.
Yes, big data is the keyword, I think.
Hi, hi, thank you. Have you looked anything at these kinds of measurements in an urban environment close to industry? I'm thinking urban settlements that are either close to, like Mo i Rana is a city where the steelworks, this ferroalloy industry, essentially in the middle of the city. You have multiple mining towns, etc., where you have urban settlements, probably smaller than the big cities, but where there's a different, at least suspect of what is the cause of noise, air quality, etc.
Yeah, we have not looked at a specific case yet, but I think every city would benefit from an approach like this. It's not, I don't mean that we have to put a sensor on every street corner and have to monitor every single house, sort of, but the resolution we monitor with today is surely not enough. So it's a very interesting case you mentioned, for sure.
Thank you. Really interesting presentation. I think I have heard KTH from Sweden and VTT from Finland giving similar kind of presentations. Just want to ask you, where and by whom should the collected sensor data be analyzed and managed?
This is a very good question, and that question will be answered hopefully when we get funding and do this feasibility analysis to exactly sort that out. We have been in contact with many actors in Norway, both public and private, and different research institutions to look at exactly that. And this is actually mostly, I think, the largest problem to not only set it all up and make it run from day one, but also to keep it running over time and manage all the data, analyze it, put the data online. This is really, really important. We haven't looked so much into detail there. This is really just in the concept stage yet, but yeah, it's very important. Thank you.
Hello. Yeah, I'm Andrew. I'm a PhD candidate at NTNU. I want to take a little bit of a different approach as we're thinking about smart Arctic cities and looking at us as researchers. I think the things I'll talk about will apply to probably other kind of approaches to Arctic smart cities, but I'm going to talk about it largely in the research context because we're trying to solve some sustainability issues as well as some other issues with Arctic smart cities, but we as researchers should also be conducting research in a sustainable way. So what is the circular economy? Sorry, I need to go suddenly to a really bright slide. The circular economy is essentially a transformation of the way that resources move through our systems. So currently we follow a largely linear model, which is depicted kind of down the center of this diagram, which is we make resources, we use resources, we dispose of resources. Circular economy is about adding loops to this process, ways that we can reuse the existing materials, we can recycle. How do we get them back, kind of to slow down, to narrow, to kind of reduce the overall consumption of resources? So when we think about this in the research context, see, there we go. I want to talk about 5 strategies for how we can begin to apply circular principles to research activities. This is not obviously an exhaustive list of strategies. If you want some more, this paper here from Bakken et al. In 2016 has some really excellent strategies. They talk about them in the context of product design and business models, but I'm going to apply them to research. So again, remember that the focus is about reducing the consumption of resources. So the first strategy here is long life products, right? So this is both in terms of the products that we produce, the research prototypes that we create, as well as the products that we are consuming or using. So in the context of the presentation we just heard, the kinds of sensors that we might deploy to measure things like noise or air pollution. The 2 major considerations for a long life product are its reliability and its durability. So how long does it sustain consistent use over time, and how well does it hold up against the rigors of regular life? And then the other is more user-focused, the attachment and trust that we design into the products we have or the ones that we choose. How much do people want to use the device, continue using these products, and how much do they trust that they are delivering for them? Obviously, if we can do both of these things, then products that we create or use can then be reused multiple times. They can last longer, reducing the need for more consumption. Unfortunately, many research prototypes look like this. Many of the things that we create are sort of hacked together to solve an individual problem. This has very little durability. You don't really trust this for long-term use, right? You're not really attached to this research prototype or whatever. We're just going to create it, use it for a study, and move on. And so we need to rethink this. Obviously, prototypes at this stage and devices at this stage have a purpose. We don't want to waste resources on creating a really nice prototype for a, early stage design, but we need to be thinking ahead. We need to be thinking about ways that we can make our designs have longer life. So strategy number 2 is how do we then extend the life of the products that we have or create. This picture comes from my master's project. We created these little handheld devices. They had a touch screen on them, a battery, and a lot of electronic components. So we're going to use this a little bit. We did some things well and we did some things poorly. There are four ways that you can extend the life of a product, right? You can make it maintainable, repairing, fixing this. Our devices, you could resolder some joints and some wires occasionally, but many of the pieces, as we were developing them, we'd have a component break and we would just have to replace it because it wasn't a very maintainable design. Dis and reassembly, the ability to slot in new components when one breaks. It's sort of like maintenance, but swapping out things. Everything was connected with glue, so this was not very disassemblable. And then you think about standardization and compatibility. We use standardized ports. We used a very common software, kind of hardware, software platform. So this was actually very standardized. You could use this in a lot of different applications, which influenced its upgradability. You could upgrade the software very easily. You could add new applications. But the hardware was relatively fixed. So we did some things well. We did other things poorly. What that allowed is that this device could be extended. Its life could be extended beyond the initial study that we used in the master's project, but only to a certain degree, right? Only within software applications, and only if we were really somewhat careful with the hardware because it wasn't very replaceable. So we can do better than this. We can design ahead. This was just a master's project. We designed some of these features in there. We can think about these things as we're creating our studies and as we're creating these products. Okay, so the next is thinking not just about the actual products we use, but about kind of the way we conduct research. So the access and performance model, if you think about a laundromat, you know, users don't need to own their laundry machines to do their laundry. How can we apply this in a research context? Well, oftentimes when we are conducting some sort of study, we will acquire maybe sensors or devices, smartphones, something along these lines, or we'll make them. And then we'll use them to run our study. Oftentimes, our funding is now finished. We've finished that project, and we're going to move on to another one, but we still have all of this hardware that's in decent condition, and we need, you know, we don't really have a use for currently. But maybe another research lab does at a different institution. So if we can think about ways of implementing this within our institutions, within our labs, of ways that we can give access to the resources that we have already purchased, maybe for a fee, renting it out to another lab to use the same air pollution sensors or something along those lines. And then that fee can then feed into a loop of where we can then replace the hardware when it's used. But we're extending essentially the life of these products because we're giving them to other people. And then that also will promote the use of long life products because we know they're going to get broader use than our single study. So thinking about this, ways that we can conduct research. And then the next is the sufficiency model. Now the sufficiency model in business terms is about reducing the kind of need for the user to consume more. So designing a long life product is actually a really good way of doing this. You encourage people not to upgrade, you know, if they have something that will last them a long time. When we think about research, this often has to do with the way we approach publications. Very much right now, the publication machine prioritizes novelty. Now, the challenge from a sustainability standpoint then is that we are constantly consuming new resources to study novel phenomena. And if we want to do better than that, we need to consider how can we reproduce, how can we iterate on existing designs so we're not consuming new resources, but using the existing resources. So it takes these two photos here is that we have this kind of loosely connected tower, which is kind of what a lot of research is these days. How can we make this a stronger pyramid of more foundational research? And then the last is updating our institutional protocols. So many institutions, especially public institutions, have strict restrictions on how to dispose of public goods, which are everything you purchase at a public institution for your research is owned by the public, owned by the institution. But there aren't necessarily good guidelines on what to do. There's limitations, what you can't do, but there's not a good guidelines at many institutions on how do we approach the recycling of these devices when we're done with them or when they break. How do we encourage reuse at an institutional level? And how do we also encourage the use of long-term long-life products, again, at this kind of institutional level? So we need to be rethinking those protocols and rethinking the way we approach that. So in conclusion, if we want to make our research more circular, more sustainable in the way we actually are approaching research, in the way, even within the public sector, how we are conducting our information gathering and all these sorts of things, we can think about these 5 different strategies. Long-life products, product life extension, the access and performance model, the sufficiency model, and then updating our protocols to give clearer guidelines to researchers. And the added bonus to this is, in addition to reducing the consumption of resources, in addition to improving our sustainability as researchers as we try to solve sustainability issues, particularly within the Arctic, is it also makes for stronger research because our research will be built on and more related to existing work that adds stronger validation to our findings, stronger just strength to our conclusions rather than constantly chasing new ideas and novel things. Which again, I want to emphasize, there is still a place for all of that. It's just finding a way that we can include more sustainable practices. Thank you.
Thank you, Andrew. Maybe we have questions. Yes.
Hi, I really enjoyed the presentation, and I was just wondering if, like, you see a lot of institutions moving towards circular economies or, models, or, like, how feasible do you think this is?
I think it's pretty feasible, but I haven't seen a lot of it. Most of the institutions that I've seen, this is somewhat anecdotal evidence, probably would be valuable to do a more systematic review of institutional policies, but many of the institutions that I've participated in have closets of old equipment, old sensors that are still functional but no longer used. Or I have been to many professors' offices who have boxes of smartphones that they used in a study and they don't know how to get rid of because the institution doesn't have a policy for that. Even at NTNU in computer science, where my department is, we don't have have any really rigorous policies there for how we approach this. You know, what do you do with these devices? You can't just get rid of them, you know, and there are better things to do than just get rid of them anyway. So I think it is feasible, though. I think it requires, you know, taking some time to sit down and think about it and come up with some policies. If we have policies on restricting the disposal, why can't we have some for encouraging recycling?
Thank you. We have another question.
Thank you for a very interesting presentation. As you can tell, I'm not Norwegian, and yeah, I work in a university in the UK, and I served as head of department for a while. And I tried to encourage the researchers in my department to recycle research prototypes. We work in electronics. I have to say the pictures were very painful for me, I have to say. But actually what I found was that people were quite resistant. People believed that their research was theirs as an individual. I don't know, in the UK, researchers tend to be quite individualistic. They believe of themselves, they believe it relates to them very directly as a person. And they were quite reluctant even to share designs because they felt it was their work and it was their research capital, if you like. I don't know, I'm just curious about whether you've thought about that sort of human, social side of these kind of issues, or whether you've encountered anything similar.
Yeah, I have a little bit. I did my master's actually in Wales, incidentally, and yeah, there was a little bit of that. Largely within labs, there was less of it, and so sometimes I think it is just broadening the conversation and helping people kind of consider ways of doing it. But yeah, this is always a big challenge, right? Is that people may not want to, or maybe it feels like too much overhead to go through all of that process as well. Yeah, that one's, I think that's the kind of thing that changes over time with conversation and with just talking your way through it and encouraging it. But, you know, in the end, you can't force people to do things most of the time. I mean, you can a little bit, right? But it's not always as effective. Yeah. But it is a very important consideration.
Thank you. We don't have more time for questions, so we'll go to the next speaker. That will be Jacob Taft, right? Yeah, good. So data and decision making for sustainable Arctic cities, and the stage is yours.
Hello, everybody. My name is Zoe Garbus, and I work with Jacob Tafridi at the George Washington University, based out of Washington, D.C. And in this discussion about using emerging technologies to facilitate sustainability action, we want to contribute by questioning who is making decisions about which initiatives to embrace and how these decisions are made. And we'd like to start by sharing a quote from the mayor of a small Arctic city we've worked with throughout our research. Here we go. So the quote is, "I guess we start with the anecdotal. What do residents keep asking about? That forms how we draft our strategic plan. Once we have a strategic plan, we need to be able to measure success. Then we look for indicators to help in that way. It is probably the backwards way, not looking at the data and the research first, but the anecdotal." So our goal within this research is to understand what role data plays in sustainability decision-making, specifically in Arctic cities. And we want to investigate what forms of data exist, how they're generated, and also how they're used. Why is this an important question to ask? Well, we think that in the context of this session, if cities want to act towards sustainable futures, they need to know whose demands or needs they're responding to. And they also need to know how innovations can be implemented. And so this is where collecting and analyzing data can be helpful. And we know that in Arctic cities, as was pointed out in an earlier presentation, municipal governments usually have the formal agenda-setting responsibilities, but we also know that local residents and organizations have very strong influence, especially in very small cities. And we also know that big industrial actors can have a lot of influence in these small cities, especially if they are, or if they have resource extraction-based economies. And so considering the roles that each of these actors can play is a big part of understanding how decisions are made about sustainability. Oh. You did it already. So the findings we're going to present today come out of an interdisciplinary research project called Measuring Urban Sustainability in Transition, and it examines the drivers of urban sustainability in 3 Arctic cities, and we're looking at how municipalities can best monitor and measure change. So we're focusing on 3 cities that have varying distributions and geographies. They are Fairbanks in Alaska, Yellowknife in Canada's Northwest Territories, and also Luleå in northern Sweden. And each of these cities is undergoing some sort of transition. They're grappling with changing energy landscapes, some of them have social challenges, and each is considering a vision of an alternative economic future, perhaps beyond resource extraction. Themes that are particularly important in each include energy, education, housing, economic futures, finance, and also health. So for example, all 3 cities are experiencing a housing shortage, but for slightly different reasons. And then Fairbanks and Luleå both have universities and thriving knowledge economies, but all 3 cities still have to work hard to retain young professionals who seek opportunities in the South. And also economic conditions vary quite a lot, as do labor demand and supply, and also health and social services. So to better understand the sustainability landscape in each city, we collected data on 128 indicators that are organized into 19 themes, as laid out in the International Standard Organization's Indicators for Sustainable Communities. And then using statistical modeling, our goal was to determine which themes best measure and explain trends in sustainability. We then supplemented the data by conducting interviews and roundtable discussions with stakeholders and rights holders in each city to contextualize these findings and find those spaces where the data wasn't telling the full sustainability story. And we also worked with the mayors of each city, and we invited them to our fieldwork trips and tried to understand and put them in communication with each other to see where there were differences and similarities.
So when we begin to talk about the findings, one of the most surprising initial things is that 26% of the ISO data was deemed to not be relevant to the study cities. And that's through a combination of modeling techniques and through just asking the mayors, do you find this concept, this theme relevant? On the other end, themes of economy, education, energy, finance, health, and housing were selected and highlighted by modeling and mayors across all 3 cities. And then if you focus just on the mayors, they emphasized education, energy, and housing as the 3 convergent themes that were relevant across. But then we began to ask sort of how do mayors actually utilize this data, whether it comes from the ISO, which is collected in Yellowknife, or often you can find similar themes in the data they collect at the municipality or national level. And it was found that indicators related to sustainability are used on a case-by-case basis, not as part of any sustainability framework that would compare trends between, things like economy and the environment and make those connections as we like to do kind of in the academic context. And we also uncovered one major disconnect, and it's that cities collect a lot of data, but it doesn't drive any decisions. Rather, constituents and political demands determine that in most instances. So this table, I don't have time to really go into it. If people have questions, we could maybe go back, and it's a bit hard to see on the screen. But it kind of just shows sort of the convergence and divergence based on models and mayors and compares across the 3 cities. And you can just maybe, to emphasize, Luleå is a little bit more interested in population and social conditions. And then these are the individual trends that kind of drove some of those models, whether they were significant or not. So we can sort of extrapolate this and come up with some big picture findings related to smart cities, especially in the Arctic. And the first is that mayors prefer constituent feedback to data. And so we have a quote from one of the mayors we work with: "I never make a plan for anything which does not include education, because that is the biggest responsibility we have. It's not because of any metric." And therefore you can see how legal jurisdiction kind of actually guides decision-making in these cities. Additionally, we were surprised that mayors were reticent to use data, even if collected from official sources like the municipality itself or the National Statistics Survey, like the Census in the US or Statistics Canada, Statistics Sweden. The difficult part is, what is good data? If I use what's available, maybe it's wrong. They could have measured wrong. So I was particularly interested in this point, and I was trying to uncover kind of why is that? Because so often we sort of trust these data sources. In many instances, data is aggregated on the annual scale, and unfortunately it's driven by point-in-time counts, which is something like for homelessness on April 20th of every year, we're going to go out and count the number of individuals experiencing homelessness. But you open yourself up to a lot of extraneous factors, just such as the weather and climate in Arctic cities, and you get a lot of variability in data, even if it's not really there. So we need better actual data collection mechanisms. Finally, indicators don't capture unique Arctic environmental issues. Arctic cities face the fastest rate of climate warming in the world. They face unique instances of pollution, climate complications, and construction related to permafrost. And many national indicators or global indicators have no capacity to account for some of these specific Arctic challenges. And they don't incorporate indigenous perspectives. This can be broken into two dimensions. The first is the demographic and social justice idea, where oftentimes you could have divergent trends for a uniquely vulnerable group, where an issue like homelessness or housing is increasing across the board. But actually for indigenous folks, it's remaining stagnant or even worsening. And without demographic breakdown, you can't capture that. Additionally, they don't incorporate indigenous understandings of sustainability. Indigenous residents are often the first residents of Arctic cities in these regions and have been stewards of the land for hundreds of years. So in conclusion, the values and agendas of the actors driving sustainability decision-making influence the outcome. Who determines what data it is you collect and how it's collected? Standardized indicator sets, such as ISO, can be a good starting point for Arctic cities to analyze trends. By using global standards, you can compare across international borders, which is helpful when data often flows from the city to state or territory to national level and often stops there. There's a disconnect between those who determine what data is collected, often in southern capitals, and those who rely on it for local decision-making in the Arctic. We need indicators that capture Arctic conditions. And so for data-driven decision-making, which we know is so critical to Arctic cities, it can really only thrive when the indicators and data are able to holistically gauge issues relevant to constituents and policymakers. Currently, we don't really have the level of data needed to actually implement decisions, and as a result, we found that mayors don't really utilize data to drive decision-making. Rather, it's political pressures and constituent concerns. So thank you for your time, and we'll welcome any questions if there's time.
Thank you very much for very interesting presentation, and that was a pretty clear presentation, in fact. Do we have any questions?
Hi, my name's Emma. I'm currently studying at the University of Akureyri in Iceland, but I'm originally from Anchorage, Alaska, and got my undergrad at UAF. So kind of two questions. One, so like the US Census, specifically this latest 2020 round, specifically found that it counted the least amount of minorities, specifically American Indian and Alaska Native, which of course Alaska Native makes such a significant part of the population in Alaska. And so it's kind of, I guess, like, at least in the Alaskan context, how can they, like, it's difficult, like, how could mayors trust such an like, it's supposed to be like the national census, and yet it's so inaccurate, specifically, like you guys said, to the Arctic context, and as well as the US in general. Also, did you talk to the mayor of the borough or the city of Fairbanks, just out of curiosity?
Yeah, so I can kind of take a stab at both questions. The second's obviously very easy. We mainly worked with Mayor Ward, who's the mayor of North Star Borough. And yeah, I don't have a perfect answer to how mayors can contend with this, but I think sort of highlighting the issue, especially in places like this, where Arctic decisions are made, is important. You need data that's accurate, and I think to sort of have some data sovereignty within the Arctic and some of the organizations that work on that is critical, where it can be tailored to the local conditions. Because as you pointed out, currently the national standards don't fare as well as you would initially think, right? Even though they're published and that's official data. But it's a great question. Yeah, thank you.
Thank you. Unfortunately, we don't have more time for questions. Thank you once again.
Thank you.
And now we go to the next talk. That will be through online Zoom, I think. Yes. So can you connect us to Evgeny Alexandrov, Smart Cities for Sustainable Arctic?
Hi, everyone. Do you hear me well? Yeah, I guess no any reaction. So I guess you can hear me. So I can just start. Yes. Hi, my name is Evgeny Alexandrov. I work at business school in the Heinous Center for Business and Governance in Buda. And sorry that I cannot attend the conference physically. And as you saw, the weather is really challenging, and I would say that I had a lot of technical difficulties actually to connect to the internet as well. So it's really, demanding right now with all this technical stuff. So what I'm going to present today, very shortly, me and my colleague Elena Dipsina, we are working on a topic on a paper that we call Smart Cities for Sustainable Arctic ? Opening up a critical debate. And the idea of this paper is actually trying to flip over a bit the arguments that we see more and more when it comes to Arctic sustainable development. Because on one side, we know a lot that Arctic can be one of the sources to secure the global sustainability, but on the other side, we also have a lot of challenges in the Arctic itself. And this relates to depopulation and low innovation capacity, governance paradox when we have tensions between local decisions and central decisions, and more like rhetoric that we really give a voice to local population to make any decisions about the Arctic. And in addition, we have this resource draining aspects in the Arctic. And what is interesting that more and more scholars, but also policymakers, they start to discuss that one of the solutions when it comes to the Arctic sustainability development and how we can secure Arctic sustainability is actually to address the smart city discussion and try to hammer and foster the use of ICT and technology infrastructure for the city needs and actually strive for sustainability in the Arctic, and also attracting citizens to live in cities in the Arctic areas. But what is really interesting, the main assumption, both by the policymakers and I would say scholars, that if we start to address smart city development in the Arctic, it will automatically come up to the idea that we will have Arctic sustainability. And there are some quotations from the previous studies saying that actually smart cities are a crucial step towards a sustainable future in the circumpolar north, contributing to a smarter approach to economic, social, and environmental development. But is it really the case? And that's the core of our paper, because if you start to dig a bit further into the literature, you will see that it's not actually the case. The relations between smart city development and Arctic sustainability is quite unclear so far. And there is more like a techno-optimistic view that, of course, smart cities can help to address sustainability. So with this idea in mind, our purpose was actually to flip over the argument and try to stimulate more critical discussion on the value of the smart city concept for the Arctic cities from what we call urban dynamics perspective. So we try to address what are the current relations between Arctic sustainability and smart urban development in the region. So how we address this issue? So how is it possible to address this critical question? So first of all, I would say that it's more like a conceptual paper because we try to bring this more critical view where we try to mobilize more international literature on what we call capturing urban dynamics, where the idea is that when we look into the smart city development, we need to move from more general discussions on technological development for the cities to how the smart city concept unfolds under multiple actors, goals, interests, and value involved in city organizing. And one of the colleagues of ours actually proposed a framework how we can look into the management and governance of the smart cities worldwide. And they suggest a framework that studies a complex set of several interrelated building dimensions to consider in smart cities in different contexts. And this is about metrics for smart city development, politics and bureaucratization of smart city initiatives, and the role of citizens. And basically, if you start to investigate these three dimensions, it's really important to consider how they interact and what are really consequences for the city and the specific context that we are talking about. So with this idea in mind, we actually try to understand smart city development as urban dynamics with implication for the Arctic sustainability. So how we do it empirically, we do not investigate or conduct any empirical studies. Instead, it's more like a combination of literature review and trying to understand what's going on with the data and different kind of reports about smart city development in the Arctic cities. So, and we made it into through the two-step process. The first one, the first step was actually to mobilize critical knowledge on each dimension of this urban dynamics and see the evidence what's going on in international literature about those dimensions. And second, we were mobilizing documents, previous publications, master studies databases, and data generated from several research projects that are investigating smart city development right now in Arctic cities. So what we can find out, so what is the idea of this paper right now? So we came up with really important concerns to consider for the future research when it comes to Arctic sustainability. And actually here we can frame several different dimensions into the play. When it comes to the role of metrics in smart city development, our literature review and also review of the secondary data actually showed that metrics do not only reflect smart city development in the Arctic, but also project particular smartness without the possibility of questioning it. So in a way, metrics can not only foster efficient and effective smart city construction in the Arctic, but also limit its development for particular interests, basically. And then when it comes to role of politics and bureaucracy in the smart city, we found out that funding structures and legitimacy pressures create a powerful visions of what is smart for the Arctic cities, with unfortunately private actors dominating the process so far. And in a way, smart city development can actually distract from the real Arctic sustainability problems and local dimensions to consider. And smart city idea can be limited to a set of more like administrative objects, downsizing more like a human-centric aspects and Arctic sustainability demands in cities in the Arctic. But then, last but not least, what is the role of citizens in smart city development in the Arctic? Here we also found out that there is more rhetoric than real engagement in the Arctic smart city development, where citizens can be actually easily marginalized. And also what we found out that participation in smart city happening not for the smart city, but more like in the smart city. And that's what we called as a phenomena of smart disconnection from Arctic citizens, where you pretend that you involve citizens into smart city development and really considering sustainability, but in practice you just introduce fancy solutions for the city without acknowledging what really citizens want in a city. With this idea in mind, our conceptual paper actually tried to foster future directions of the Arctic smart city and sustainable cities to address by future studies. I'm not sure that I have time to go through them, so that's why I will just go into the conclusions. So again, if we come back to the main point of our interest area, whether actually smart city can address and foster Arctic sustainability. Based on our review, we found out that it's not actually the case. So, and instead, as you saw, there are really important critical concerns to consider and several areas of research to go on. So our paper has several academic implications, but also policy and practice implications. When it comes to academia, we try to open an alternative debate to explore the complex relations between smart city development and Arctic sustainability. And in particular, we show the pitfalls of seeing a smart city concept as a panacea for sustainable Arctic urbanization and suggest further questions to be addressed. How we can overcome those pitfalls. When it comes to policy and practice, we also open an eye on quite problematic but often hidden side of smart city development that demands carefully translating the concept and its promises into the Arctic context. Yes, I think that's it from my side.
Thank you very much, Evgeny. Do we have questions? I do not see any? Sorry.
Hi, Carolyn with Alaska Command. I'm not super familiar with smart city concepts, so can you dive a little bit deeper into what I thought you said was smart cities rhetoric leads to more marginalized and disconnected communities? Did I hear that conclusion correctly? And can you explain it a little bit more?
Yeah, thank you for this question. I hear some echo. Is it possible to turn it off? Yeah. It's a good question when it comes to the smart cities, because if you start to see what is smart city, it's quite ambiguous concept in general. And that's the main problem, because there is no one common definition or one unified definition what is smart city. And also it's actually the space for a lot of manipulations, how we start to address this concept in different contexts. And what we see, at least in the Arctic context, that's exactly what is happening. We see the more like a dominance of particular interest and dominance definition, what is smart. And this definition is, how to say, mostly driven by technological companies and IT companies, and I would say more like a neoliberal ideology, unfortunately. And as a result, we see that in practice, it becomes, maybe we can even call it new, how to say, recolonization mechanism of defining what is really important to consider in the cities in the Arctic area, without acknowledging really the local needs and local citizens dimension.
Thank you. Unfortunately, we have no time for more questions, and we will now go to the last talk of this session. Victoria Miles, Measuring the Resilience of the Arctic Cities. Please, the stage is yours.
Yes, hello. My name is Victoria Miles, and I'm researcher at Nansen Environmental Remote Sensing Center in Bergen. Yes, using remote sensing, we can measure, we can map, and we can analyze different features of urban environment. But as it mentioned today, very often, so without human perception, without human eyes, knowledges, understanding, so we cannot go further and cannot measure the resilience. What is Arctic urban area? So it has some similarity, but anyway, it's very different than cities in low and middle latitude. So the city is isolated and located far from each other. They don't have transition zone between urban area and surrounded tundra ecosystem. So they very much depend on heating, and most of them built on permafrost. But what is similar, so it's totally artificial environment, and it has own soils, vegetation, and own climate. And using remote sensing, we can measure the urban climate, and here you see that Arctic cities has the same phenomena with other cities. So they have such climatic phenomena which called urban heat island. And here you can see that urban area of Kiruna is much warmer than surrounding. And this is profile across the city, and we see this so-called dome, which is kind of which is called urban heat island because its temperature is much higher above the urban area. So we use a land surface temperature measured by satellite. So it's not the same, it's correlated with air temperature, but basically it's, we can kind of describe it as a temperature when we touch object by hand. We made studies of 7 largest cities in the urban Arctic, so it's Boda, Tromsø, Murmansk, Apatite, Rovaniemi, Lulea, and Oulu, and we observed urban heat island in each of them. But here you can see the graph, so it's average summer temperature. The blue is a rural temperature, and the orange is the urban temperature. So we see that variability, inter-annual variability is very similar, and we have the increasing trend, but the urban temperature is always warmer. And here is an example of a strong summer land surface temperature anomalies in city of Rovaniemi in Finland. So I see. Yes, and actually we observed that this effect, this urban anomalies, they last in a city for many years or even sometimes decades. So this is a study of dendrochronological analysis in city of Nadim. So dendrochronology, it's like annual growth of city, and the city develop a ring, and the width of the ring correlated with the temperature. By measuring the growth ring, we can reconstruct the temperature. So, and here we see, oh, sorry. So here we can see the location of cities. This is an urban area, and this is airport area, and this is modest land surface temperature. We can see warmer urban area during summer and winter time. And this is dendrochronological graph. So we see that blue one is non-urban area, and it's like 15 kilometers from the urban trees located, sample trees located from 15 kilometers from the urban area, and burgundy line indicates the urban area, and here we can see that increase of radial growth correlated with development of cities. So it's like, we can see it's like in 1968, the trees in the urban area get a big increase. So this is also because the urban area warmer, but at the same time also that upper layer was destroyed, and this insulation and lichen area was removed, and the soil get warmer. So this is kind of larger satellite data with a high scale. So this is Landsat image. So we also can observe that urban area is much warmer than surrounded tundra ecosystems. But inside of the urban area, we also see very big variability. So some areas is warmer and other is cooler. So what is urban areas? So this is so what kind of impact in urban heat island? Mostly it's built infrastructure. So this is built infrastructure is our city of Tromsø. So we see that it's kind of a variability of different buildings, bigger and smaller, and this building have different density. So, and the color indicate the temperature, surface temperature of the building. And here we can see that bigger buildings is much warmer than smaller buildings. So this graph indicates here the smaller buildings, they have a big variability, but bigger buildings still are above the average. So they are warmer, so they basically they contribute on local heat island, plus they also have contribution on the bigger urban heat island in the city. This is, we calculate the vegetation maps for the Tromsø, and we also see that some areas have very high vegetation and other buildings located in non-vegetation area. So here is like we see these big buildings with big flat roofs surrounded by asphalt, and of course they're much warmer than buildings surrounded by vegetation. So we can see that their size and density in material is influential factor, but at the same time the vegetation is a shaping factor for urban heat island or local urban heat island. So yes, green spaces in the Arctic is very important. Most of the people who live in the Arctic, in Arctic urban city, they are very valuable for vegetation and green spaces because it's kind of like it's what mostly from the spaces where places from where they come. So here, and you can see even the most northern city of Longyearbyen, people try to grow some flowers. Even this is kind of like a place with invisible wind. There is no trees and people cannot see wind there. And this is example from Reykjavik. So people try to imitate Mediterranean garden, and so this city and urban parks in Nadim and Fairbanks. So, and how can we collect information and how we can get perception? So this is kind of, yes, we can develop special citizen science project to collect information. So the prototype of such project we developed for a city in Bergen. It's called Bergen Booster, where we develop special GIS-based map, which can be downloaded on a phone, and people can use it, and all information coming, and we collect it on our GIS. Can be presented to a GIS dashboard, and then can be presented to urban stakeholders. So, and this is kind of like in a way we're planning to do it in our new project, just like to combine ecological and social factor, and we'll develop a ranking indexes. So, and as conclusion, yes, urban building, they have a big effect on a local microclimate, and but mitigation, of course, have very big effect. And of course, we have to use people to get their knowledges, get information from them, and get their reflection on urban spaces. Because actually, especially in Arctic place, the green urban environment is very important for the people because they kind of cannot use surrounding area, and quality of urban areas is essential here. Thanks a lot.
Thank you, Victoria. Do we have questions? Yes, Johannes.
Thank you for this great presentation. I'm curious, you showed surface temperatures of buildings. Did you measure those with satellites as well? And if yes, what resolution can we expect from satellites?
30 meters. But,
30 meters?
Yes.
Oh, yes. That's impressive. Yeah. Thank you.
More questions? Yeah, we have one over there.
Yeah, thank you for the presentation. Just curious about if you have incorporated materials in the kind of what materials the buildings are, like on the roof, is it asphalt plating, or are they dark, are they glass, stuff like that?
No, we didn't do such analysis, but we just used Google Maps, just made some visual interpretation. So, and you can see it's quite well, so the shape of the roof. But of course, if we want to do further analysis, we can get this data. So especially now, here's all this data, not some of the data available. Yes, thank you.
Thank you. If there is no more questions, then thank you once again. I have a suggestion, because we are a little bit late in this session, and now is coffee break. Then we go to coffee break and move presentation of posters after the next session, because we will have much more time before lunch than now, and I don't want to be in a hurry very much with this presentation. If you're okay with this, then now we will have coffee break.
Good afternoon. Today I have a privilege to continue with a very interesting sessions which we start in the morning about health, well-being, smart cities and other things. So here I'm today replacing my dear colleague from NTNU and SINTEF, Sobach Peterson. So I will just present the first part about the whole session, and then also to start with the session from Sobach. So today in this session we are going to start to listen to different topics which are related with health, well-being and transformation of the cities. And this from different focuses, from literature review about health inequalities, digital solutions, and very interesting successful practices in Arctic environments regarding health, well-being, air quality, and energy demands. The first one, which I'm going to present, is from Trondheim. And it is about digital technologies, energy, health and well-being nexus. Okay, how to go on with that? Is that? Next, okay. The presentation here, what we have here is more about not only the digital world, but it is about why we try to find another language to discuss serious topics about transformation, about environmental issues with citizens. We have so many different stakeholders. We are addressing many people around, and not all of them understand the knowledge, especially scientific knowledge, also, or let's say the language, scientific, academic. So we try to present in different forms in a way that we can discuss easier and closer to them. So here Sobach is part of one of the bigger projects, and in this project she really focused on digital tools which are connected more with gamification and other presentations. So here she wants to address people in the language which could be recognizable, for example, with smiley faces. So somehow that the emotion on the other side are presenting the successful or less successful stories or our practices. And for example, she designed a tool, app, which is a kind of user interface with many information behind. So here we can see on the app on the left side, there are many informations, and smiling Earth as a metaphor is showing at the end of the focus, and in the end of the story, you can see the results. And the results are connected with our actions. And this is something which we were addressed at the beginning, actions, reactions. So somehow, based on the knowledge, based on information about our actions, we can also understand better how to react in different way. So the smiley faces here show how much CO2 we are consuming by our actions. If we change behavior and walk instead of taking our cars, then we are, of course, producing less CO2 than somebody else. So smiley face, it means on the left side, it means that we are really working very hard and try to change our behavior. So it's less than 4 unit of emissions. And in the middle, it means that we are close, we are still less, but we are very close to the edge, to the border. And on the right side, when smiley face is not smiley, Earth is not smiley anymore. It means that we are producing much more. So in that way, the game is, so let's say the app is showing some different possibilities. If we are using solar panels instead of different, let's say, as energy resource, if we are walking, if we're cycling, or using cars. And this is really interesting, even more interesting, because at the end of the day, it's not only measuring one time, but it is constantly measuring. So by that, we can see that the diagrams on the right side, we can see that from a longer period of time, we can see that there are changes. And if we changed our behavior, so it's constantly somehow measuring our actions. In another project, and in this project we work together, it was accessibility of solar panels. It was about use of solar panels as an energy resource, and also how to change from another source of energy to solar panels, let's say a more energy friendly. And we try to engage citizens, and for that it is very important to show the pictures which show the situation on their locations. So it is not imaginary picture, and we have many students, we had many students behind that, and this is one of the master theses. And in this one, it is shown how what kind of information people need in a way to understand better what is the benefit out of that. On left corner, upper left corner, we have the area, and it is Molenberg area with beautiful old traditional heritage protected wooden buildings in Trondheim. And on the bottom part, we are seeing what kind of parameters could be measured. And the parameters are about the size of the buildings, orientation, and any kind of parameters which show if it's useful to have solar panel, and also to calculate how much we can produce out of the solar panels. So then the app, which is given here, the app is showing somehow estimations. So people can just go to the map. They can go directly to a location which they're interested. It is prepared only for Molenberg. And then they can get out the information about how many solar panels they can use, on which side to put, what is the financial outcome of this, and what is, of course, energy benefit out of this. It shows different perspectives. Also here you can see on the bottom level what kind of choices you can choose. The reflection about that. It is about the concept of linking energy consumptions, transport medium, personal health and well-being, and that's why we try to come closer to people and to say, look, if you are interested, we are here and we can help with all kind of information, but it is also kind of engagement tool. So to also to raise up the knowledge and information, and also how to use the others. If you are interested in the research, here are some other sources, and you can also send questions to Sobach, because I'm just representing her here. Of course, if you have any questions to discuss now, I can try, but it is not my topic. Thank you. Any questions? No. And I'm happy for that. The next one is Johannes Hoem, and he will talk about very interesting practice from 2 Arctic fishing communities about energy.
Thank you. Yes, my name is Johannes Hoem. I work at the university here in Tromsø at the Department of Physics and Technology. And I'm here today to present the Smart Senja project and some of the results from that project. Yeah, so what I'm going to go through in these next 8 minutes is a little bit of introduction on electricity in Norway, a little bit of a backdrop for those non-Norwegians in the audience. Then a little bit about the project, what we have learned, and also how it is relevant to the subject of this session, or at least I'm going to attempt to do that. So wish me good luck. Norway is a very weird country, energy-wise. We have almost 100% renewable in the energy mix. 90% is hydro, and about 10% is from wind power. You very often hear people talk about energy transition, and it's also a word that's used a lot in connection with this project, this Smart Senja project. But for most countries, that's about transitioning from fossil to renewable electricity production. In Norway, that's not so much the case, but it's also a little bit the case. I'm going to touch on that later on. But the only thing you need to remember for now is that we have a almost 100% renewable grid and energy supply of electricity. And since it's mostly hydro, it's also very flexible in terms of production. It's not only the way we produce energy, which is weird in Norway, it's also the way we use energy. It's very different from the rest of the world, especially since we use electricity for almost all heating purposes. So around 80% of all energy consumed by households in Norway are used for either heating water or space heating. This is because electricity has been traditionally very cheap in Norway, cheap as chips, or actually cheaper than chips, since we have very expensive potatoes in Norway. But and this is of course, some would say that this is wasting electricity, but in many ways it also is a blessing in disguise, because this gives us a lot of loads to work with in terms of flexibility. We are also probably the country in the world with the highest number of EVs, or electrical vehicles, per capita. Last year, I think around 80% of all new cars that were sold in Norway were electric vehicles. So yeah, weird country, Norway. But this is just a backdrop. So what is, or first, what is Senja? It's the second largest island in Norway. It is connected to the mainland with a bridge. Probably not today though, it's probably closed, but so by all practical purposes, it's a part of the mainland. But it is at the end of the grid. As you can see, these yellow, green, and dotted lines on the map here is the so let's see, we have a laser here. Yeah, the dotted lines here are the main, the national grid, and this is the distribution grid. As you can see, they are at the end of the grid. And even more so, these two communities, Husøy and Senjahopen, that are the focus area of this project, and hence the title of this lecture. What can we learn from two Arctic fishing communities? They are very centrally located in terms of fishing resources. They export fish from this island worth 10 billion Norwegian kroner every year. I think the small community of Husøy alone, with around 300 inhabitants, export for over 1 billion alone. Lately, these communities have been experiencing a lot of challenges with their access to electricity. I'm not going to go into details, but basically there's been a problem with rapid voltage drops, and these voltage drops causes big issues for the industry. Oh, I'm running out of time here. So that's why the university partnered with the local community, the fishing industry, and different tech companies to see if there was any way we could utilize the existing grid in a smarter way to avoid these problems that they have on the island. And one thing is the problems they experience, but it also, of course, limits the amount of electricity they can use for new purposes. For instance, electrifying their fishing vessels, and also modernizing some of the processing plants for fish. In short, we've been looking at three main things. One of them is installing the largest grid-integrated battery in Norway. Oh yeah, that's the next slide, sorry. The first thing we're looking at is flexibility, looking at what kind of loads we could move around in order to create a more flexible grid. The other one was installing the largest grid-integrated battery in Norway, both at Senja and at Husøy. And also attempting to install some local energy production that has been proving very difficult. So to the results. We are halfway in the project now. We started in 2019, and we're going to run out until the beginning of 2026. And so far, the battery and the flexibility has been a success. We are limiting the amount of faults that we are getting in the grid, and also now new customers are allowed to start using electricity. So we have a new charging station that is being built at Senja now because of these batteries and the flexibility options, and also the local fish processing plant at Husøy are able to expand their production. I was there on Friday, and they're just now getting a new transformer installed as we speak. Okay, 30 seconds. So why is this relevant? The issues that they were experiencing, this is an electric ferry, the first one in the world, actually. That's running in Norway. And this is why the problems at Husøy and Senja are relevant to the rest of us, because in many ways they are telling us about the future that we are going to experience when we start using more and more electricity at the same time to electrify the transport sector. It's only logical and also very both good for the environment and the bank to be able to utilize the existing grid in a smarter and better way.
Thank you.
Sorry.
Thank you very much. We have applause.
Questions? Yeah.
We have only time for one question, if there is any question. Okay, yeah.
Hi. Could you explain a little bit more the background for these voltage drops that they were experiencing?
Yeah, why they're caused. It's a combination of bad weather and overconsumption. So when you have overconsumption, the voltage drops, and then if you combine that with bad weather and other factors, then you will get these small, they're called blinks locally because that's how they materialize. You see the lights are blinking, and this is causing, even though the voltage drops are short, they are causing problems for the fish processing equipment that can last. You have to shut down the equipment up to like an hour in order to get it started again. And then you can have like 5, 6, up to 10 of these during a day, so you can imagine.
Thank you, Johannes. We are going on to another presentation, and this one is going to be digital. So we are going to connect with Kyla Little. She will talk about connecting energy transition across the Arctic. Hi, Kyla.
Hi.
You can start, please.
Okay, perfect. I will just share my screen. So today I'm going to be talking on behalf of my colleagues, Regine Kennelly and Elena Adesheva-Klein. We're all 3 PhD candidates across 3 different universities studying 3 different areas of the Arctic, and we came together to connect our learnings and our knowledge and hope it paints a bit of a picture of the differences and similarities in energy transitions across the Arctic. So as we know, the Arctic is warming 4 times faster than the rest of the world, and this really presents the urgency of such transitions in the north. The Arctic is also an international region which shares environmental and socioeconomic similarities and differences. And across the Arctic, unlike Norway, unfortunately, 80% of communities rely on diesel to meet their energy needs. So it's a really fossil fuel dependent part of the world as well. And I'd like to thank the UArctic Academy for Sustainability for bringing us together last year and allowing us to have these conversations across our 3 case studies. So the first one is my research, which is based in Iqaluit, Nunavut, which is the capital of Nunavut, and has about 7,000 residents currently. It is the largest city in the territory. It is a northern territory in Canada, which was created in 1999. So it's our youngest territory here in Canada. I'm based in Canada as well, and it relies on diesel generators for electricity and is a completely isolated grid, much like the rest of the territory. Much of the infrastructure, especially its energy infrastructure, is aging and coming to kind of end of life stages for the technology. And we've seen success with community energy projects such as the Renewable Energy Cabin Grant Program, which has electrified over 100 cabins with solar panels. So this is kind of a really brief example of how local community is eager for renewable electricity, and you could see that with the positive uptake in this solar panel program. The next example is from the Faroe Islands, which is a self-governing nation within the Kingdom of Denmark. It's a sub-Arctic archipelago with 54,000 residents. And much like all examples in this, it's an isolated grid. It's an island grid, so it can't be reliant on a national grid system. It has a really high potential for renewable resources such as hydropower, wind, photovoltaic, biogas, tidal, and solar. So a really wide range of renewable resources are available on this island or in these islands. It's also garnered quite a bit of international interest. It's seen as an island laboratory oftentimes because of its isolated nature, but also all the potential that's on the island or in the island, sorry. And there's also been an extreme increase in energy consumption in recent years, and this is due to increases in various industries, such as salmon farming. So we can kind of see how not only are we thinking about energy transitions, but also energy intake and increases. And these are just some photos from examples of model tidal kite sources and other locations across the islands. And our third and final example is Tixi in the Arctic Russian Arctic. And it's again another isolated grid. It's a wind diesel complex is what supplies the energy. So there's an old diesel station, a new diesel station, and then some wind turbines that also provide power. So you can kind of see this hybrid example that has come out in other areas of the Arctic as well. The wind park was built and managed by Russian and Japanese energy companies, so we can see the similarities to the Faroe Islands in that international actors are playing a role in the energy transition here. And originally the wind park was experimental, but it continues to produce energy. So you can kind of see another similarity there with trialing different technologies in remote and Arctic climates. And there's also been an increase in diesel, or sorry, a decrease in diesel due to this introduction of wind to the community. Oh, okay. So now this slide is just talking about the similarities we've come across in our discussions across our case studies. So most obviously is the climate conditions. They're all considered Arctic or subarctic conditions. So this can pose challenges to technologies that have not been tested in these conditions. There's also the remoteness. They're all considered remote locations and not accessible to larger population or more dense population spaces. And they're all isolated grids. They are not connected to national grids or international grids or anything of the sort. So they're all have to be self-sufficient in that sense. And there's this perception of fossil fuels in all three locations as the most, oh, sorry. There we go. As the most familiar and often reliable energy source in technology due to its established use in the communities. So we can really see how individuals are reliant on that kind of safety, especially in harsh conditions where energy blackouts or anything like that can really be a serious concern. And you may not have a lot of time to get the electricity back up and running depending on heating sources as well. And there's also this inability to use backup sources. So there's, like I said, they're isolated grids. You can't rely on another community if your power goes out, and they need to be self-sufficient in this sense. Some of the differences that we're seeing is access to capital and international investments. As I've mentioned, the Faroe Islands perhaps has the most interest at the moment. So there's international interest, not only investment-wise, but to test technologies in the area, whereas a community like Iqaluit does not have that international interest. So it must be domestic sources. And oftentimes even the domestic sources are minimal, and it really has to be local drive for this. There's also limited access or variations in access to emerging and diverse technology. as I said, the Faroes is a great example of this diversity of technologies and this interest in emerging technologies and testing it in the area, whereas Tixi and Iqaluit do not have this interest or this sort of testing beyond our solar panels and our wind turbines, which are kind of beginning to be established technologies. There's also infrastructure gaps in the local infrastructure, as I mentioned in Iqaluit, and as you saw in Tixi, there is issues with aging energy generation and diesel plants. And then there's also limitations placed on local population growth in Iqaluit due to infrastructure, limited infrastructure capacity. There's also policy and legislation gaps that we've noticed across different areas. There's a lot more flexibility in the Faroes currently with the current policies in place, whereas in Iqaluit there is quite a bit of the policies are catching up to the technology. So although there's been community interest, there might not be policies in place to allow for that a trial and error with new technologies. There's also issues with access to land and space, and this could both be physical space and ownership. So the Faroes are islands, so that's a very physical limitation on space. And then you see in Iqaluit, there's very specific rules around land ownership due to the nature of the territory and how it was established. So you can kind of see that land ownership is not so much of a thing there. So that creates a bit of a tension as well. And then finally, our rising energy consumption. This is not so much of an issue in Tixi and Iqaluit as it is the Faroes, where they're seeing an increase in industry, which is causing that energy rise.
Hi, Kyla, can you just wrap up because it is the time is
Okay.
just passed.
Okay. So those I'll leave the conclusions on the screen. But that was the bulk of my presentation, was those similarities and differences. So thank you so much, and hopefully we have time for a question.
Question time? No questions for us, so you are very clear. Thank you once again.
Okay, thank you.
Thank you. Next one is Elham Andalip. She will talk about built environmental factors' impact on health gap and inequalities.
Hi everyone, my name is Elham Andalip and I'm from NTNU Department of Civil and Environmental Engineering. I'm a PhD candidate under supervision of Alenka, and today I'm going to present to you the built environmental factor impact on health and well-being. We all know that built environment impact our daily life. The built environment is a place that we work, live, and do all of our activity in it. But it's a complex relation between built environment and health, and how it makes this interaction possible. So we had 3 research questions to answer in this literature review. The first one was, what element of the built environment can affect citizen health and well-being? The second one was, what diseases are caused by this built environmental factor? And the third one was, what measures and methods are suitable to fix this kind of complex relation between these 2 sciences? So I know the chart is very small, so please accept my excuse for that one. But I have a little bit information here to answer these 3 questions that I said before. We found 2,819 papers from 4 databases, and with so many exclusion criteria, like removing data about noise pollution, air pollution, and also non-English papers, and so many other exclusion criteria, we came to 71 papers that got the answer out of it. So we found out built environmental factors affect physical health, mental health, social health, well-being, quality of life, longevity, and mortality. And as Johannes and Victoria mentioned, one of the factors that affecting this kind of mortality rate is urban heat that affect the health. And it was interesting for me also that in Oslo there was one paper that says that the effect of urban heat on mortality of people are considerable. But today, because of the time limitation that I already passed 2 minutes, I'm going to only cover 10% of the data that I found in this literature review. So the first one is built environmental factor on mental health. We found out that built environmental factor affect stress, cortisol level, schizophrenia in children, mental disorders, suicide rate, sleep problems, depression, mood status, and perceived restoredness scale. And what built environmental factor affect this kind of issue is greenery and natural environment. That 65% of the papers emphasize on the impact of greenery, the safety and crime rate in the neighborhood, that how it allowed people to go outside and experience the outdoor environment, the neighborhood design and also architectural design, that how it allows you to be social and be in public spaces, and how the nature are designing the neighborhood, how is the accessibility, how is your daily life experience of the neighborhood, and also the leisure facilities and the city network and accessibility. But I cannot go through all of these factors, so I will say one of the diseases that can have highest rate with the built environmental factor, which is suicide. The long distance to the city center was mentioned as one factor that affects suicide. Isolation, when people feel isolated and don't have access to the public and social area. But it's not about only access, it's about how these kind of social and public spaces encourage you to use it daily and visit more often. So the design of these public spaces are more important, that I will refer to it in the next slides. The lack of educational spaces and training spaces, and little or no presence of nature, and living alone, which is very important factor. The second one, which is about physical health, we found out that built environmental factor increased the rate of cardiovascular diseases, breast cancer, blood pressure, sleep again, and obesity in children and elderlies. What built environmental factor affect this kind of diseases? It's light pollution and night light which affect breast cancer. It's residential greenness and street trees, parks, walking distance. All of this can affect cardiovascular diseases and other that I mentioned. It's exercise and relaxation area, the public spaces again, social meeting spaces, neighborhood density, and your house size, and the density in the house size, which is suitable for you or not, and local facility, transportation, and accessibility again, and diversity and accessibility. So I again refer to one of the diseases, which is cardiovascular disease. The research shows a 1% increase in the green space will reduce all cause of mortality. And about the cardiovascular diseases, also the percentage of reducing the cardiovascular diseases by greenery is important. The morphology of the city, the ability to move around and have activity, but this activity have to be daily for at least 15 minutes a day. The safety and crime rate that wants you to be eager to be outside and have activity, and the design of that spaces, and what facility you have. Is it, for example, liquor shop as a next to your facility, or is it a shop that you want to visit? And also the aesthetic and visual quality of the places. The street have linkage and also a space syntax to their surrounding texture. So we answered the second question, but not all of the answers, just 10% of the answers, that what diseases are caused by the built environment. But what about the first question, which was about the element of the built environment? As I have talked during the different diseases, the greenery and social and public spaces has the most literature about it. So the greenery have to be in different level, from macro level to micro level, about landscape, city greening park, to the micro level of roof greenery, to the terraces, to flowers and everything. So it will have impact in different level. And the view you have from your house, the combination of the visual environment with natural acoustic was very impactful, more than just the view. And also the winter vegetation, which is important in Nordic countries. And the natural green spaces were more efficient than the man-made green spaces. And the number of visits, which was emphasized in most of the papers. But what was considerable about the lack in the research was what type of greenery do we need? Because the most researcher was about, we need greenery, but what type of greenery do we need? Exactly for what things? For example, the paper that I talk about, the Oslo and urban heat, it was talking about we need special trees to reduce this kind of mortality rate. But what about the other diseases? What type of greenery are suitable for this? The next one is about social and public spaces. The paper says that environmental characteristics of the social infrastructure are important. And the best situation is that it will be combined with nature, and also the distance from each residential area is important, that people will be eager to visit it more often. The presence of people sitting, so we need more people, but also we need this kind of social spaces that allow you to have some private situation if you don't want to be between all people. So we need a variety in this kind of public spaces. And also the safety again, and also the wall painting and some graphic to reduce the safety, to reduce the crime, not safety. And also the street light and the situation needed for these public spaces. But again, there was a lack of good information about the architectural design of these social spaces, which help you to have a better health and well-being situation. And about the connection of it to happiness, I couldn't find any information. Okay, sorry. And about the conclusion and implication, I think this information need to be added to the health guidance to reduce the public health gap in the society. We needed more information to contribute to the health equity, and also to enhance the quality of life of each people. And also, we need, for what I felt during this research, is that we need to convey this kind of information more to society so people can choose more wisely what their neighborhood should be, what the area they want to live should be. And we need to send this message to our community more. I don't know how, but it really bothered my mind in a way. And also, we need to provide the guidance for community. So thank you, and thank you for listening to me.
Thank you. Questions?
Thank you. I have a question about, you're talking about the effect, how building elements of the built environment are affecting various kinds of health risks. Are you talking then about a causal relation or a statistical correlation? Because, I mean, it's a variety, like schizophrenia in children and so on and so forth. Have you any reflections on that, whether it's actually a causal relation or just a statistical correlation?
Actually, I found several methods that affecting this kind of different factors. I mean, each paper was based on this statistical correlation, but also interviewing with different stakeholders. But what I found was a statistical correlation between different factors.
Thank you for a very interesting presentation.
Thank you.
Did you think about pets? The space to walk dogs, for example, and an urban environment where it's compatible with having dogs, I think has some quite interesting social effects in terms of people's mental health and also cardiovascular health and that sort of thing. Did you think to look at that kind of element of the built environment?
I didn't find it in my literature review about this kind of effect of having pets, and you are completely true, because I know people who have dogs have to daily walk their dogs to the parks and different environments, but I didn't find any information, but that's very interesting to consider in future research. Thank you.
Thank you, Elham. We have to move forward. We have another presenter, Regina Pshenko. She will talk about emotional well-being of elderly residents.
Hello, my name is Regina and I'm a PhD student for the Nordic Arctic Federal University, which is located in Russia, Arkhangelsk. And today I will be presenting part of our research we have done on topic emotional well-being of elderly residents as a prerequisite for sustainable development of Arctic settlements. I have been working on that topic with my supervisor, Tatiana Valentinovna Zhigaltsova. She is attending that conference in online format and will be glad to answer questions in online. And here is some keywords for our research. And emotional memory is a memory of previously experienced emotion. Emotional memory of a place of residence is an indicator of the presence or absence of feeling of place. What is emotional memory? It is an emotional connection or emotional roots connecting an individual with a place of residence, the loss of which leads to a loss of sense of security or sense of home and lead for the formation of feeling of placeless. Emotional memory is strongly influenced by the architecture side and appearance of a place itself. Rural areas create a stronger feeling of place, but why? To begin with, several generations traditionally live on the same territory. The space is familiar, every place is known. There is also the absence of strangers. Everyone knows each other directly or indirectly. And finally, the environment itself is better adapted to the daily needs of the residents. However, many of these territories in modern times can be called depressed territories, and they are subject of such global trends as the aging population and outflow of working age youth to larger urban cities. As a result, there is a negative impact on the sustainability of development of these territories. Therefore, the most important issue for us was preservation of the emotional health and well-being of elderly residents who remained on that territories, and search of tools and practices that help sustainable development of small historical rural Arctic settlements. The special attention we paid for transformation of the architectural and ethnographic environment from the mid-20th century till present time. So, we researched the village of Solovetsky Island, Solovetsky, and Pomorian villages Temytsa and Kanda, the word-use methodology of emotional geography developed by Tatiana Valentinovna and has presented in publications, which you can see on that slide. And this summer, I interviewed 17 older residents of the village Solovetsky, and Tatiana Valentinovna conducted 18 interviews among the older residents of the village Temytsa and Kanda. In addition, we carried out archival research in local museum and regional archive and the Russian Ethnographic Museum. The collected materials we show in our interactive maps, screen of which you can see on that slide. But yes, so what classification of emotion we use to show on that slide is places of emotional attachment, that is a positive emotion such as joy, interest, comfort, pride. They are colored blue and green, and emotional rejections are such as negative emotions, sadness, disgust, anxiety, and shame. They are colored orange and brown and red. And during the interview, in the settlements of Kanda and Temytsa, two other emotions were highlighted by interviewers, such as suffering and resentment. And I'm going to go closer to the results of which we conducted on Solovetsky Island. And before I will review the results, I will be presenting the factors which influence the architectural sites and emotional memory of that territory. First of all, that is an island, so that is territorial isolation, such as marine environment and its island nature, and the relatively late formation civil settlement, the religious history of that place, because there was a monastery and there exists a monastery till present, and finally that location used for special purpose places such as Solovetsky special purpose camp, Solovetsky special purpose prison, and then naval unit from 1939 till 1991. And that's why a significant portion of the local population either being the settlements of the employers or prisoners or of the military personnel who served and lived on Solovetsky Island. So, during the interview, respondents didn't identify themselves as indigenous people, but they rather maintained detached position, so they felt themselves as a guests. One of our interviewers says that there are no indigenous people on Solovki. So us locals are not interested in changes. We are not ready to take care of the places where we lived. And basically, we can say that, or interpret that, there is a process of formation of local identities that take multiple generations. In context of a stage of identity formation, moral emotion, such as pride and shame, are the most important and the most interesting. According to the results of interview, 35% of responders refrained from expressing their opinion regarding the places of pride on Solovetsky village. The feeling of shame was associated with main bay and its ecological state. So, responders especially highlighted the sea. 45% of responders identify sea or coastline as a place of interest or comfort. One of the responders said, "We're glad to see the sea. This is air for us and water. The sea is everything for us." Two of responders feel uneasy about the sea and due to intense anthropogenic pressure and changes flora and fauna. And one of our responders had an allegory that sea is a connection with ancestors. Most responders described feelings of sadness pointed to the cemetery. A woman who lived in the village said everyone there in the cemetery have someone. However, the other responders say that they attributed that place with joy. The difference of opinion is due to personal beliefs and cultural and religious norms and values. The other interesting thing is Beletskaya bathhouse or Beletskaya banya, which was a public bathhouse from 1717, firstly used by monastery people, and then it's from mid of 20th century till 1990s was a public bathhouse, and then that was not just a bathhouse, that was a social place where people come to communicate with other local people. And now it's no longer used as a bathhouse. People are missing that place a lot. Almost each responders say us about that place. The study indicates that current period is still characterized by the process of formation and construction of local identity, which gives the weak emotional connection to the local residents, to the place of residence. So, to strengthen the sense of place and physical-emotional connection with one's place of residence, it's necessary to pay attention to the architecture side, a lack of social venues, and insufficient number of social events. When drawing conclusions from all data for all the residents, we can see that culture heritage sites, such as historical houses, churches, outbuildings, not just places of interest, but mostly place of pride, which is base to the formation of the positive territory identity and strong feelings of place. Social venues also strongly contributed to the feeling of place and sustainable development of small Arctic settlements. Thank you for listening, and we will be glad to answer questions, me personally or my supervisor via email.
Thank you for a very interesting presentation. Any questions? I will ask a question because it is today we are talking about sustainability, smart cities, and so these emotional reactions are very interesting also, not from isolated small places, but how do you see connection with changes in bigger cities and environments?
I think that is really important. Thank you for your question. I think that is really important because, yes, in small settlements in the Arctic region, it's more and more outflowing of young population. So we have to find ways how to save environment and architectural side for people who remain there and provide them like good type of environment where they can feel themselves comfortable, because it's also an environmental problem and not, it's a lot of different things which is come into, into what is happening now, going on now.
Thank you. We have the last presenters today, and this is Maria Alonso. And she will talk about indoor environmental quality and energy efficiency, please.
Yeah, thank you. It's good that you took the selection, your what's the name? You didn't take indoor quality as a part of what you research. So today I will talk to you about the smallest brick, probably, of smart cities, that is a single building. And exactly on that, I will tell you about how we can improve ventilation by taking into consideration indoor quality. So this is the normal house. Let's say if we move right after the war, buildings had to be built very, very quickly, and nobody really cared about how airtight was the building envelope. Suddenly, we realized that buildings, they were consuming a lot of energy, and then we needed to do something. Basically this, making buildings much more airtight, that were wasting much less energy, but also had a small drawback. That was that all these pollutants, let's say combustion from making food or showering or so on, suddenly were trapped within the indoor environment. You were somebody talking about that we are using in the Arctic much more diesel. Well, all these particles would be trapped inside the building, making us having a lot of problems. So when it comes to ventilation, that was the next step when we made a very airtight building. Then building codes, a little bit different in every country, but more or less all of them, they said you should focus about ventilating for persons, the pollutions that people are breathing out. You should also ventilate for furniture and whatever is making pollutants that may be brought into the house. And finally, you should ventilate for any specific activity if you have it. Let's say if you have a kitchen, an industrial kitchen, you should ventilate for this industrial kitchen. The Norwegian one, what they say is that you take either persons plus materials or pollutants for activities, and the largest one of both is the one that you use for ventilating. But if you see here, we say that when people are there, we ventilate with an amount of air, and when people are not there, we ventilate with another amount of air. But how do we know these people is there? And basically, how do we control ventilation? Business as usual is that we measure CO2. Everybody's breathing at a very well-known and studied rate. At least when you are all sitting, you are breathing at a constant rate. What happens to select the maximum CO2 that we know that you are producing? We think, okay, which is the maximum level that I can allow before people are realizing that it smells people? And based on that, we say 1,000 ppm. If you have less than 1,000 ppm, you will not smell that people was in the room. But you are there sitting, very calm, very happy, but I am here standing, and of course I am sweating much more than you. So if somebody comes after a lot of people sweating, then this 1000 ppm is not going to be good anymore. So putting a limit that is based on others and that is very fixed, at least when it comes to CO2, is not the best way of attacking the problem. We also have another problem that a lot of research has been done on CO2 and how it affects us and the well-being and health and so on, but it's very difficult to study CO2 alone. Normally, when we made all these tests of how CO2 is affecting, there is other pollutants in the room that are affecting all these three parameters. So then we realized that there are some other things in the air that are affecting much more our health than CO2. And one of them is particles. For instance, all these diesel generators, but also when we cook and so on, we are making pollutants that are going into our health system and give us cancer, for instance. We have formaldehyde, that is a gas, and is very connected to all the glue and paintings that we are using. And this one is connected to allergies or cancer again. And the third one, that is one of the biggest problems in the cold areas, is the relative humidity levels, that they basically affect the other two, but also they will affect our perception of the indoor air quality. So when it comes to ventilation, this is a normal system. If you forget this, if you forget the blue line in the middle, this is a normal system. We supply air into the room. We, after let's say, if there is people there, you are considering like about every hour, you are taking the equivalent volume of air and putting it outside and changing it with new outdoor air. When you take outdoor air from room, so for example, at minus 10 degrees, and you warming it up, the very little amount of humidity that you had in the room is already gone when you warm it up, because you get into very low humidity levels. And that's the reason why what we propose here is to use recirculation of the return air. And what we do is that, sorry, the laser, you don't see it, but with these sensors, in my case, I use low-cost sensors. You can measure the air quality. You focus on the parameters that you know that are in the room, and those are the ones that you use to control what is the quality of the air. If the quality of the air, because there is very few people, is very high, you can send it back again, probably with a share of the outdoor air. If there is a lot of people or a lot of sources, then you are not interested anymore in recirculating air. So with new low-cost sensor technology, we have the possibility to do this. In my PhD, what I was working with, it was to quantify how much energy can we save while ensuring that we have good enough and healthy indoor air quality. What we realized is that you can simulate both, and you can make very simple control strategies that are based on logic. Sorry that you cannot read them, but basically what we do is like, we look at the quality inside the room, we compare it with the outdoor air quality, and we try to see how does it affect both energy and indoor air quality. And I will show you two cases. One is in Trondheim and the other is in Beijing, because they were very good, very easy to compare both of them because of the outdoor air quality, because of the outdoor air temperatures and humidities, but not for the outdoor air quality. In Trondheim, what we conclude is that the second line represents the business as usual in an office building in Trondheim. When we start using recirculation, then you go to the ones on the top. And those that are using recirculation based on particles, so outdoor air quality, they are the two last, the second last and the third last. So we can reduce the energy needs to about 1/3 of the business as usual, while we can make sure that we have good indoor air quality. And this we know because here we are looking at the, sorry. Can you hear me if I talk very loud? Here in this graph, what we see is the quality of the air. Oh, yeah. Yeah. Here in this graph, we see the quality of the air. And I don't know if you see it, but here what we see is these two represent the two cases where we have recirculation of extract air, and we can increase the humidity levels in winter time, while we are keeping a satisfactory temperature and our CO2 levels are within what the standard says. In addition, what we can do in Trondheim is probably not so important because the outdoor air quality is very, very high, but we can keep the lowest amount of pollutants. So the exposure to to dust is the smallest. But what happens in Beijing? Here, if you see this line here represents the outdoor air quality in Beijing. When we are using ventilation, like constant air ventilation, this is the exposure that people are facing, around 10 times what the standard says that is healthy, or at least not unhealthy. With recirculation of extract air, well controlled, we can see that we are within what the standard recommends. So very quickly, to conclude, what we can do with recirculation is that we can reduce the exposure to dust, and we can make systems that increase probably the most sad problem in winter in Norway, low humidity, but without using humidifiers. And then probably the most important lesson that I got from the whole PhD is that if you want to measure, you need to have measurements that are reliable. So it's not only setting a lot of sensors, but to make sure that they are good enough to provide real data. At the moment, we are trying to make a new project to work on that. So if somebody wants to discuss on that and join the project application, please talk to me. Okay, thank you for your attention. If you have any questions, please.
Thank you, Maria. Questions?
Okay, I have a very simple question. You are talking about humidification, but in many houses the problem is exactly opposite, that humid air will condensate in the colder places. How you're dealing with this?
So this is the whole thing. You recirculate if you can recirculate, otherwise you don't. Normally you condensate because either you have low temperature at a single point or because you have too little ventilation. So if you are having a mechanical ventilation that you can control the airflow rate, you will look at the places and both at the temperature and humidity, and then, like let's say, you are never going to recirculate from a bath. This is the first step. And normally you have problems of mold, probably in the bedrooms, because they are often the coldest point in the room, and the profile is very different, the profile of production. So you just make sure that you don't recirculate during night times, most likely, because also you are going to have the highest CO2. So you just need to control exactly the quality of the air in the room before you decide to recirculate. There is also an effect of when you take the air from the whole building and you mix it. So then you are also going to balance this high humidity that you may have in the bathroom, because you are mixing it with the humidity of the living room, the humidity of the kitchen where there is no people, so then the level is actually getting lower. But you need to know, what do you have from the return, what do you have from the outside, and then make the decision on what is the level. And of course there are moments that you are not going to recirculate. If you know that you have a thermal breach, please don't recirculate, or at least fix the thermal breach first.
Thank you, Maria. We have another question and then we will finish.
Thank you for the interesting presentation. Yeah, I just don't know a lot about this area, so I was just interested, what are the advantages of recirculation over just putting a humidifier in the room, for example?
So humidifiers, we are very afraid of them because what you do with a humidifier is that you have a place where you are storing water and you have risk of Legionella, Aspergillus, and many other bacteria that may grow. And when you put these bacteria into the air, you just spread them everywhere in the room. That's the reason why you don't want to have a source of that. And what he was pointing out, if you have a cold place and you put humidification, then you may have a lot of problems with condensation. So that's the reason why, use only if you have a guitar shop that you need to keep the humidity in the room.
Thank you.
Thank you, Maria, once again. This is the end of the sessions. Very interesting, very informative. So even we as professors learned a lot. And now it's eager to end the session and to invite you.
Poster presentations.
Where are the poster presentations?
Now.
Where?
Now we have, yes. We have also a short presentation of the poster session. So there will be slides like this on a screen, and authors of these posters, please say a few words about your poster. I cannot read who is the author. Elizabeth Perry. Here? No? Okay, next. Ah, that's me. I'm here, actually. So welcome to my poster. During the poster session today at 5:30, it will be about high-resolution urban meteorological data fusion. And the whole point here, we have very different sources of data. How to fuse them together so we get holistic information about air and meteorological environment in the smart cities. Next. Sophie. Not here. Next. Li Hong.
Hello, everyone. I'm PhD candidate from the Arctic University of Norway. And in my poster, we will explore the world of offshore wind energy. And as you all know, Norway, abundant in offshore wind energy, has set its ambitious goal for offshore wind energy. The government has taken a significant step by identifying the potential offshore wind development area. As indicated in the left figure, you can see the blue polygon show the potential wind energy development in northern Norway. But before we start to construct the wind turbine, we need to assess the offshore wind energy resource so we can maximize the wind production. So this is where the high-resolution data can be our guiding light. So in this study, we'll explore the potential of Sentinel-1 satellite data, because you may ask, why Sentinel-1? As equipped with the synthetic aperture radar, the Sentinel-1 provides us the wind speed data and wind direction data at a spatial resolution of 1 kilometer. And apart from that, Sentinel-1 can perform well in all kinds of weather, particularly in polar region, which has limited daylight. So,
yeah, Li Hong, just invite people to your poster.
Okay, yeah. Welcome to my poster. It will begin at 5:30 today. Thank you.
Next. Good.
Juha Saunavaara, Hokkaido University Arctic Research Center. I kind of forget that I need to say something here. But just again, if you are interested in talking about data center industry and its role at the crossing point of green transformation and digital transformation, come to see my poster. We can talk about the problems, challenges, and possibilities that Arctic cities and northern cities have to attract new data centers. And we can also debate on whether or not Arctic cities should actually attract or invite new data center investments, or many other issues related to data center industry. Please come if you have any interest. Thank you.
Thank you very much. Okay, was that all? Yeah. Okay, so, and now we will end our session. Thank you very much to all speakers, and thank you very much to all participants who actively participate in this and previous session, asking questions. I hope to see many of you during the poster session, actually all of you plus new people during the poster session, and continue discussion there, and maybe also after the poster session at the reception. But now we have time for lunch, which we shouldn't miss. Thank you once again to everyone.